Hello, and welcome to everybody to another episode where I ask, what's up with the universe? I'm your host, Elihu Who, and I want to welcome everybody who's new and everybody who is a continuing viewer of the stream here. And I just want to remind everybody to don't forget to give a thumbs up or a thumbs down. Either or, it's up to you. If you haven't subscribed yet, don't forget to hit that subscribe button. And if you do subscribe, don't forget to ring that bell so you know exactly when I go live, or pop a little video up now and then. I want to welcome people who are in the chat. Big shout out to thanks to LDG Geeks and Joy Neurotica. He helps me sometimes with my computer issues. And hello, Shifty Gizms. Yes, where are they? Come on, everyone. Where are the aliens, really? Hello. Hello, universe. I'm not Anton, but we are actually going to talk about the aliens. Yes. I mean, where are these guys? Is anyone out there? I mean, do aliens exist? Well, this might be the most popular question you get when you talk to any astronomer. We are going to explore today the possibilities of life in the universe with the explanation of the Drake equation. Yes, the Drake equation reviews each of the factors that contribute to the likelihood of intelligent life in our own galaxy itself. One of the big questions is, what are the chances there are other intelligent civilizations in our Milky Way? What are the factors to consider when we think about finding other intelligent civilizations? From the earliest time we can think of, the night sky has evolved in contemplation of our own origins. I mean, where do we come from? Are we alone? Only in the last half century has scientists weighted on the big topic there. The science of astrobiology is actually a combination of astronomy, biology, genealogy, meteorology, and many other different sciences. Francis Drake, he is one of the founders of science of astrobiology. He was born on May 28th, 1930, and yes, he is still alive today. He is also one of the founding members of SETI, the Search for Intelligent Life. And I have to say this real fast, Kaplaber. Drake, he began searching the skies with the radio telescope in his 60s, before the idea of life elsewhere in the universe was even considered a serious scientific purpose. The next year, he was preparing for a small meeting about a dozen other scientists interested in the search for extraterrestrial intelligence, ETs. By putting together the agenda, he came up with 7 factors that he thought would be relevant to determining the number of other intelligent civilizations on our own Milky Way galaxy. From this, we got the Drake equation. Yes, the Drake equation. Let me make sure you guys can actually see this right here. Shown here at the bottom of this presentation right here. We don't have any right answer that we know. It is simply a look at all the factors that we need to consider when speculating about the existence of intelligent ETs. We'll have many guesses to evaluate odds of finding ETs in a huge galaxy, but don't worry about all the letters, okay? These dots just mean we're going to multiply them all together. N is what we are looking for. It is the number of civilizations in our galaxy right now that are able to communicate over interstellar distances. That's what we're going to estimate here. We are thinking about whether there are aliens out there to communicate with. Okay, let me give you an example of what we're going to do, and here is one of my favorite foods. Pizza. Yep. I do love pizza, by the way. Okay. Say you're like Bernard Pride 5, who's hanging out in New York City for some odd reason. He left his house, which is a miracle if he ever did. But say he's wandering around New York City. It's 10 a.m. on a Sunday morning, and you happen to be oddly craving a Hawaiian pizza with anchovies. Okay, minus the anchovies. A Hawaiian pizza for some odd reason. Okay, I love Hawaiian pizza. Yeah, okay, Sumi, I love Hawaiian pizza. You're looking for a pizza place, okay? You find a lot of pizza places. Now that you're looking for one that's open on Sundays, and that just happens to be opened up very early. And of course, one that delivers But do they deliver to your neighborhood? Of course, you want to make sure they serve pizzas with pineapple. So little by little, you narrow down your searches. It is possible that a restaurant that will deliver pizza to your neighborhood at that hour with pineapples, but then again, maybe not. We're going to do the same thing we're gonna do with pizza, but we're actually going to look at aliens. Okay, like I said, N, the number of stars in our own Milky Way galaxy. Let's take a look at the first factor. The first factor is, yes, there is intelligent life on Earth. But the first factor, how many stars in our own Milky Way galaxy? We know that there are hundreds of billions of stars in our own galaxy, but we don't have the exact amount. Okay, let's see if we can work together to make an estimate. I'm going to get us started with the first factor, N. It's actually pronounced N star. I'm going to say just general estimate of 400 billion stars, okay? So, which fraction of stars have at least one planet? Remember, I said 400 billion. We start with all the stars in our galaxy, but we're not going to find life on all the planets rotating the stars. For life, we need these planets here because studies of exoplanets are rapidly discovering how many stars have planets. I mean, the Kepler mission alone has got over 4,000 exoplanets discovered. Okay, I said 400 billion. We are looking at the F sub P factor. So, what is your estimate for the fraction of stars that at least have one planet around them? Don't worry, you can guess all you want and you cannot be wrong. So, how many of these worlds have the quote-unquote right environment? We're not just looking at any planet. We might want a planet with the right environment for life. We call these habitable planets. They're within the habitable zone, the Goldilocks zone. So, how many of these habitable planets do you think are around each of these stars with planets? Okay, let's talk about exactly what we mean by habitable. Big gas giants, they're way too violent with no surface to speak of. Life that we could actually recognize would most likely develop on a small rocky world like Earth has, or Mars, or possibly Venus. I mean, also, it needs some heat source. Of course, what is Earth's heat source? It's the sun. I mean, we are in the habitable zone, or Goldilocks zone. Not like Mercury, which is too cold, or Mars, which is too cold. We are right in the center of the Goldilocks zone. See, we have 3 planets in our habitable zone, but we are in the Goldilocks zone. The habitable zone, like I stated, was the area where life could possibly develop within the sun's rotational plane of the orbit. But like I said, we need liquid water. I've discussed this on my show before. Water, liquid water. Earth is not the only really place we know that has discovered liquid water. We have liquid water flowing on Mars. We have evidence of liquid water on 2 moons. And I'm going to talk about those in a few minutes. See, to get some clues on what alien life might need to survive, we're discovering different organisms that survive in extreme environments right here on Earth. These are called extremophiles. They are organisms that can live without sunlight or oxygen. Others live under intense pressure or survive in the vacuum of space. I mean, these possibilities could seem endless, but one thing that they all have in common is that they all need liquid water to survive, grow, and reproduce. Just bouncy bow wow. It has some amazing properties, such as being able to coexist as a solid, liquid, and vapor. This is water. It's also a common ingredient found throughout the galaxy, which is a good thing because we are looking for planets with water. I mean, chemicals on Earth are common throughout the galaxy, so water is probably common on any planet that's warm enough to support it. I mean, in our solar system, right here in our own solar system, 2 planets, Earth and Mars. There are also 2 moons around gas giants that may have oceans, that actually have oceans of liquid water beneath the surfaces, Europa and Ganymede. Titan and Enceladus, Ganymede and Enceladus, I forgot. I apologize about that. Ganymede and Enceladus, I was mixing up my moons here. These have water. Europa and Titan has not been confirmed to have liquid water around under the surface yet. We are still exploring. Of course, does that potentially make them habitable? So the next factor asks, what's the average number of habitable worlds around a star with planets? Well, this narrows down our search even further. Okay, let's take a look back at those worlds that have some right environment to support life. I'm sorry, I just got some noise from loud neighbors here for a second. Okay, F. How many habitable planets develop any life forms? Of course, the next question is how many of these planets with hospitable environments could actually go on to develop life of any kind, even basic single-celled organisms? Let's start with what we know. How many planets do we know of that has developed life? Well, just one, Earth, our home. I mean, for this and many other factors, we only have a single data point, our Earth. This makes it almost impossible to be accurate in estimates, but guessing can be instructional too. Okay, I'm going to make a simple timeline of life on Earth. Okay, the Earth formed with the rest of our solar system about 4.5 billion years ago. If the Earth formed at this, right here, a fingertip, and this fingertip here is today, when do you guess that life developed on Earth? Just about this much right here. Because just as soon as Earth started getting bombarded by space rocks and the oceans formed, we have evidence for life. I mean, somewhere here on my forearm, so life has just begun around Earth's history. We don't exactly know when life began on Earth. We don't know exactly how life began on Earth. But that's one of the joys of science. We always have new questions to answer. But does knowing that life begins so early in Earth's history give us any clue about how easy it is? It might be life be given anywhere in the universe under the right conditions? Or was it just unique to Earth? I mean, this is what this factor looks at. So, how many would you be excited if we found some other version of algae or other planets on another planet or a moon? It might not be exciting as alien civilizations like us, but many planets do, we think, develop other kinds of life. Okay, let's get down to our search aliens, what we might be able to talk to. I mean, how often does life become simple intelligent like us? The next factor that the likelihood that intelligent life will eventually form on a planet with simple life. We each have our own definition of intelligence. Dolphins, for instance, they certainly display complex thinking skills. Crows are able to sense emotional from people and recognize faces. I mean, will these species ever look into space and wonder about civilizations of other worlds? We don't know. I mean, back to that timeline from before. All the animals that we can imagine, from jellyfish to dinosaurs, they developed here on most recent hand, basically in the last 500 million years. There are simple organisms for most of the Earth's history, but complex organisms are a recent development here. I mean, even more interesting, the entire history of humanity on Earth could be erased if I simply basically look at a clock and erase the last 2 seconds of the Earth, 22 seconds of the Earth. Yes, cats are intelligent. They recognize your name, but they refuse to acknowledge it. Okay, FC. How many intelligent civilizations communicate? Even if aliens are smart, can they even talk to us? Well, humans have actively sent out a handful of messages into space. It's expensive and we aren't sure where to direct a message. We're currently just mostly listening. I mean, right now, our TV signals are too weak to show up as anything but noise across interstellar distances. You're not going to go to another planet 4 light years away and hear the Honeymooners episodes. No. I mean, if they have the technology, it is possible alien civilization might detect not to communicate. We don't know the answer to this, and we can only guess right now. In case you're wondering, this radio telescope is the RT-70. It's in the Ukraine. This is one of the telescopes that sent a handful of interstellar messages. And on the top right is the Arecibo message written by Frank Drake himself and others. It was broadcasted only once in 1974. It was directed at a globular cluster M13. That's about 25,000 light years away. Okay, L, the average lifetime of a communicating civilization. The last factor is perhaps the most difficult prediction of all. Our technological civilization, it was just born. I mean, we will be able to survive the many dangers and any other species have encountered. So, what are some of the ways that our species might not survive? Some of them are shown here, like asteroid impacts, droughts, natural disasters, wars, plus climate change, famine, pandemics, AI, overpopulation, Prometheus failing, turning into Skynet, all that good, wonderful stuff. But some philosophers think that if a civilization becomes advanced enough, it could, in theory, continue forever. We don't know. I mean, not only are we only communicating civilizations, we know life on Earth is uncertain. L is the average lifetime of a communicating civilization. And it has started. Yes. Prometheus, pandemics. Yes, it has started. The TG factor. It's the age of our galaxy, but this is fairly well established around 9 billion years for the bulk of the Milky Way galaxy itself. So, the range of estimates. Where does this leave us? Because almost all these factors are basically considered wild speculations that predict the number of civilizations in the Milky Way varies wildly. We could be alone, or there can be an intelligent civilization fairly near to us. Again, these numbers here are based on many estimates and don't accurately tell us the number of civilizations. But of course, they do make us think. I mean, if this number is 1 or less, okay, we predict that we are not alone in our galaxy. This will make us very special. Unfortunately, the closest big galaxy is Andromeda, and any signals we might receive from there would be about 2 million years old. Plus, we would have no way of sending back such a strong signal. If the number is less than 10, with this few civilizations in the Milky Way galaxy, we would be very lucky indeed to find them. Right now, most of the planets we are monitoring are in our corner of our Milky Way galaxy. To say there is any few civilizations, just hoping they contact us first. I mean, if it turns out that really are that many intelligent civilizations in our own galaxy, we can hope to hear from at least one of them. We may even detect the presence in sky surveys that are looking for planets around nearby stars. I mean, in the meantime, so we haven't detected any ET signals yet. But we are looking and listening. I mean, it's important to note that we haven't found any credible evidence for life elsewhere yet. I said credible evidence, okay? No alien ship has hovered over the city and landed yet. We've only seen videos and images, clips, and people fake those, and some of those are speculations, and some of those are considered real, but we have no credible evidence of life elsewhere. But there are serious scientific studies being conducted around the possibilities of life beyond Earth. For instance, the NASA Astrobiology Institute, it's a group of researchers with a mission to study the origin, evolution, distribution, and the future of life on Earth and the universe. The SETI institution, which was founded by Francis Drake, SETI stands for SETI is the Institute listing for signals for extraterrestrial life. Extraterrestrial evidence, sorry. Yes, I can't talk again. The SETI at the Home project, that's basically anyone listening with the effort from the home computer. They're going to be starting it up again. SETI at Home. I will put that link in the description. I forgot to do that. I apologize. If you're interested, you can help search NASA Kepler mission with NASA at Home. That the link is in the description as well. For future explorations, it is possible that we are alone in our galaxy. But if we are not, we are very well be able to detect alien life in the not too distant future. I mean, our current instruments right now, they're becoming more advanced, and we are actively exploring the possibilities of life in our own solar system. So many people will ask, when we do detect life, how is it going to change humanity? I mean, what about other communicating civilizations? So how do we search for planets, basically? I mean, around other stars that may harbor life. Even our own biggest telescope, we see a star pouring us light. The stars are so far away, we can't measure how wide one is or even see that they're around. For most of the part, we can't see the tiny planets orbiting them. But there's a secret hidden in that starlight, and it's not Pink Floyd. You ever see what happens to white light when it goes through a prism? Let me show you. Just like that. It makes a rainbow. Like I said, it's not Pink Floyd. But it's similar. I mean, we send starlight through a similar process. We see a rainbow of colors. Here is an example of starlight spread out. What do you notice? There are black lines throughout this thing. These are called gaps in the spectrum. I mean, these lines give us valuable information about the star itself. For instance, look at the star here. This is a simplified version of what we might see from a star. Those lines happen because the white light coming from the star, it must first pass through the star's atmosphere. Yep, if you remember back, I talked about stars, they have atmospheres too. The ingredients of a star's atmosphere, they block very narrow areas of color in the rainbow. Each ingredient has its own unique set of lines. So what does this tell us? This tells us what the atmosphere of the star is made of. These lines represent a combination of many ingredients. So let's see if we can figure out what the ingredients of the star's atmosphere is. This is the element helium. Does it look like helium in the star's atmosphere? Do the stars line up? Yeah, it does. That means there's helium in the star's atmosphere. But we only got part of that little puzzle. There's more to it. Let's see what else is in a star's atmosphere. Let's cover up the helium so those lines have been figured out, okay? What about oxygen? Do oxygen's lines fit? Nope. So that means the star's atmosphere doesn't have any oxygen. So, how about hydrogen? Do the hydrogen's lines fit up? Yep. So the star has hydrogen and helium in the atmosphere. Sometimes a planet will pass in front of the star we're observing, dimming the light. This is called the transit effect. I mean, if we spread out the light as the planet passes in front of it, we find something very interesting. The starlight also passes through the atmosphere of the planet, giving us some valuable information. So this hypothetical star here, let's remove the lines of hydrogen and helium we already found and see what else is in the rainbow. Not much. Can you figure out what else is in this planet's atmosphere? Well, we put the three components here together here so we can compare all of them at once. It's carbon dioxide. And yes, is there any water? Nope, no water. I mean, this planet has a carbon dioxide atmosphere, something like Venus, our own solar system. Unfortunately, we're looking for planets with environments that contain life. That is, we want a planet with water in its atmosphere. I mean, okay, the transit image of planet WASP 10b as it crosses the disk of the star, the brightness of the star decreases, allowing scientists to measure the preciseness of the planet itself. To say, how about this planet? I mean, what ingredients does this have in its atmosphere? Which of these lines match? Oxygen, water? Say we saw all these lines of the planet pass over the star. It might be a good place to study further, because finding water in the atmosphere is very exciting for astronomers. Gases like oxygen, ozone, and methane would be promising as well. I mean, these gases disappear out of atmosphere quickly unless something is constantly producing them. And of course, that's how we take light from stars and learn about the atmosphere of planets. And no, they don't need to be taken from orbits. They can actually be taken different telescopes here on Earth. That actually reminds me, LDG. I'm going to actually put the link in here so you can actually help look at some of the telescopes that actually do help detect this. And I do try to make things simplified here. So If I did not, I want you guys to take a look at this little clip here produced by Space Plates to explain exactly what I said.
Space Place. In a snap. Searching for other planets like ours. Earth is the only planet we know of that has living things on it. But could there be others? Do planets outside our solar system, called exoplanets, also have living things? We don't know, but NASA scientists are looking. They watch the starry skies for planets similar to Earth, ones that are about the same size, that are just the right distance from their star. We call this distance the habitable zone. It's where the temperature of the planet would be similar to Earth. A planet about this temperature could have liquid water on its surface. Water is necessary for life here on Earth, and it is probably necessary for life on other planets too. We don't know what living things on other planets would look like, and they might be so small they could only be seen with a microscope. So how do we find planets that could be homes for living things? We look at stars. We watch other stars closely to see planets pass in front of them. When a planet crosses in front of a star, it's called a transit. The planet blocks a small amount of light from the star. We can see a very small change in the star's brightness. This is how we can tell there could be a planet there. A NASA spacecraft called Kepler has found thousands of exoplanets this way. Future missions will be searching too. And who knows, maybe one of those exoplanets could be a home for living things. Find out more about other stars and exoplanets at NASA Space Place.
And I want to thank everybody for joining me here today, and hope everybody has a nice evening and a good weekend. So don't forget, as a reminder, I'm doing a 24-hour live stream on August 22nd, 9 p.m. Pacific time, at midnight Eastern time. So have a good night, everybody.